Not only can tornadoes be looked at a regional or a continental scale, but individual tornadoes can also be examined. Let's take a look at one day's worth of tornadoes, and also let's consider hailstorms and lightning on that particular day, and maybe how about some windstorms, just general windstorms on a particular day, and see what the pattern is of those storms on a particular day. Did they start in a certain place and spread out over that day? Were they localized? Let's just take a look at one day's worth of severe storms and see what it reveals spatially and temporally. Let's get started.
Let's investigate one-day patterns of tornadoes, wind, and hail using ArcGIS in a lesson called Stormy Weather. What you'll do in this lesson is to work with data and maps to understand the spatial and temporal distribution of tornadoes, wind, and hail. This lesson uses ArcGIS Desktop 10 software from Esri. Earlier versions of the software could be used, but the best results will be achieved with ArcGIS 10. This activity can be used at a variety of levels from upper secondary to university level. Questions could be modified depending on the level targeted. Students should be familiar with maps and some basics of physical and cultural geography and some GIS to most effectively use this lesson. This lesson includes 50 questions. Estimated time to complete them is 4 standard class periods for a total of 3 to 4 hours. Or it could be assigned outside of class with an estimated time of completion as 1 to 2 hours or possibly 3 hours. The investigation could be extended to 1 week of 5 class periods, allowing for class presentations to be made, or even further with additional tools used or different weather phenomena investigated. Or a subset of the questions could be engaged within 1 or 2 class periods. These questions and problems can be posed by an instructor in a one-computer classroom with a projector, engaging the students in discussion while using the ArcGIS tools, or in a computer lab setting where students are working on their own computers. In a lab setting, students can work independently or in groups through these problems. The skills involved are as follows. This lesson includes analyzing spatial point and polygon data, symbolizing data, data and file management, selection, sorting, querying data in maps and tables, working with map projections, creating summary tables, and creating and analyzing data in graphs. These lab sheets are all you need to run the lesson. However, you could easily extend the lesson by investigating additional days of tornadoes, wind, hail, and other events from the NOAA Storm Center, or other data sets depending on the questions you wish to ask. One resource for this data is, as you can see right here. You could also determine which cities had the most hail, wind, or tornadoes near them on 22 April 2011 or any other day. You could also create a tornado, wind, or hail density and a 3D surface using Spatial Analyst and 3D Analyst respectively. If you extend the lesson, please consider submitting your extension as a lesson on ArcLessons. edcommunity.esri.com. Let's get started. To recap, in this activity, you will 1. Examine a predetermined single day of tornado, wind, and hail in the USA using ArcGIS Desktop 10 software. The day we will examine is 22 April 2011. And number 2, download and examine a different day of tornado, wind, and hail data of your own choosing. You will also use spatial statistics to help understand the pattern of the tornadoes, and you will also compare the pattern of your one day of tornadoes to historical tornadoes. Here is the problem. You are a researcher with the Federal Emergency Management Agency, or FEMA. FEMA is asking you to assess recent tornadoes, wind, and hail so that you can understand the extent of recent events and allocate necessary resources for emergency mitigation. Included in your assessment will be an analysis of the tornadoes, wind, and hail for one day, and compare it to historical tornado touchdowns. You will also download and analyze tornado, wind, and hail for a different day of your own choosing. Let's open up our map inside ArcGIS Desktop. Let's just make the tornado touchdown layer available and visible. These tornadoes occurred on 22 April 2011. And here is the pattern of the tornadoes. Describe that spatial pattern of tornadoes. How many tornadoes, according to this data set, occurred on this day? So let's take a look at the attribute table. We've got 26 tornadoes listed on that day. Which state saw the most tornadoes on this day? You'll need to create a summary table to answer that question. It's quite simple to summarize any table of data in a GIS. Let's say we want to summarize on state name so that we can determine what state saw the most tornadoes on this day. First, open the attribute table. Make sure I don't have anything selected. So I'm going to clear the selection. Then click on this field that you want summarized, in this case state. Select Summarize and give it a home. Where do you want it to be placed? I want it to be placed in the same data set, and I'm going to call it Summary Tornadoes. Excellent. Done. Open my summary table. Got 1 in Kentucky, 3 in Arkansas, it looks like, 3 in Illinois, 6 in Oklahoma, and 13 in Missouri. This summary shows me then that Missouri saw the most tornadoes. Now you can repeat that process for windstorms and hailstorms. Name at least 2 reasons why windstorms are destructive. Let's take a look at the wind data. Do you think that windstorms are more common or less common than tornadoes? Why? Name at least 2 reasons why windstorms are destructive. Do you think this data includes all windstorms on this day or just the major ones? Why? Describe the spatial pattern of major windstorms on this day, 22 April 2011. Name at least 1 aspect of the wind pattern on 22 April that is similar to the tornadoes, and 1 aspect that is different. How many wind events, according to this data set, occurred on this day? Are there more wind events than tornadoes on this day? Does this confirm or deny your statement above about the frequency of tornadoes versus wind? For wind, select the state field and summarize, saving your summary table in your working folder. Open your summary table. Which state saw the most wind events on this day? Alright, turning our attention to hail now, which are hailstorms, these white stones here. Let's go ahead and turn off the wind. So here's our hailstorms. Do you think that hailstorms are more common or less common than tornadoes? Why? Name at least 2 reasons why hailstorms are destructive. Describe the spatial pattern of hail on this day in April 2011. Name at least 1 aspect of the hail pattern that is different from the wind. Name at least 1 aspect of the hail pattern that is similar to wind. And what about similar or different from the tornadoes? How many hail events occurred on this day? Are there more hail events than tornadoes on this day? Does this confirm or deny your statement above about the frequency of tornadoes versus hail? For hail, select the state field and summarize, just as you did before, saving your summary table in your working folder. Which state saw the most hail events on this day? Alright, so which was most common? Tornadoes, wind, or hail on 22 April 2011. Do you think that the frequency, as we have examined here on this day, is about the same on this day as on other days? Now let's turn our attention to temporal analysis. Storms not only have a spatial pattern, but a temporal one as well. In this section, you will analyze the temporal pattern of storms on 22 April 2011. Sort the tornadoes attribute table on the Object ID field. Highlight the first few records in the table. And move the table so that you can see the map. See those cyan dots? Those are the ones we're looking at right now. Let's highlight a few more. Down here, and there's one up here now. Repeat this process for the next few records and so on until you are at the end of the table. Observe how the tornado touchdowns move as the day progresses. So here's the middle of the day. Now they're all up in here. There's a couple down in Oklahoma still. Of Missouri into Illinois and Indiana and Kentucky. Describe the movement of the tornado touchdowns as 22 April 2011 went on. Repeat this process for the wind and hail layers. Compare and contrast the movement of the wind and hail during 22 April 2011 compared to tornadoes. What was the primary direction that the storms moved that day? The times given in the data tables are in Zulu time, or Coordinated Universal Time. Let's take a look at this time scale right here. See the following table for converting UTC to the time zone in the central USA during the time of the tornadoes, Central Daylight Time, or CDT. Here is the conversion table that I was talking about. What was the range in hours from the first tornado to the last tornado that day? What was the 2-hour block that you would say encompassed the height of the tornado activity that day in Central Daylight Time? Can you find any single time where more than one tornado occurred? If so, how far apart were these tornadoes on the map, in distance? Do some research on the tornado at the St. Louis Lambert International Airport that occurred that day. Describe what happened during this tornado. Here is the tornado that we're examining right now. Main terminal windows blown out at Lambert Airport. Roof off of Concourse C, power outages. That's this one right here. Describe what happened during this tornado. Name some problems that could arise if a tornado happened at an airport, as it did here. Look at your data in your GIS. What time of day is indicated in CDT for the tornado? What was the latitude and longitude of the tornado? Describe the location of this tornado in relation to the pattern of the other tornadoes that day. And as you can see, there are others in that area. Describe any wind and hail events. Here's hail. Here's wind events that occurred near the location of this tornado that day. And resave your map document. Let's change our analysis now and examine some cities. Use the Measure tool to answer the following questions. How far was the center city of St. Louis from the airport tornado? What major highways was the St. Louis Airport tornado near? How far from the closest other tornado on this day was the airport tornado? What other major cities were there tornadoes near to on April 22, 2011? And you could examine the other ones that are close to cities on that particular day in April. So what we've done is we've analyzed tornadoes spatially and temporally. We've looked at the relationship between cities and tornadoes. We've also examined one particular tornado that caused damage at the St. Louis Airport. In this section, let's calculate the mean center and standard deviational ellipse. This will give us a better sense of the distribution and spread of tornadoes, windstorms, and hailstorms on this particular day. What is a mean center? Calculate it for the April 22 tornadoes. And here it is. I've labeled it with a T. The mean center, or the point at which the tornadoes would balance on, is right here, T. Let's do the same thing for wind. The wind center that day was over here on the Missouri-Illinois border. What about the hail? It is a bit southwest. So let's take a look at hail and find out why. Well, because there were quite a few hailstorms down here in southwest Oklahoma, and that pulled the hail mean center that way. In terms of wind, there were quite a few windstorms reported that day out here in Indiana and Kentucky, so that pulled the wind mean center over that way. Now let's calculate the standard deviational ellipse. Once I do that, for tornadoes, I have this oval. Inside this oval is one standard deviation above and below the mean. And so it encompasses one standard deviation of all of the tornadoes. You can see the shape, you can see the size. What about for hail? Hailstorms are more spread out, and so the shape and size is larger. Let's just take a look at the attributes here. We can see the area and so on, and the XY coordinates for the center of it. Excellent. What about for wind? The wind is even larger as far as one standard deviation, because the wind actually was quite spread out, as you can see here. We've got some wind all the way up into Ohio. Okay, well, interesting. Which phenomenon, tornadoes, wind, or hail, has the largest standard deviational ellipse? Does this match with what you predicted earlier? Then we're going to go ahead and save our map document. So by a couple of simple calculations, we have a better understanding of the distribution of tornadoes, wind, and hail. The next section of the lesson has to do with comparing one day of tornadoes to historical tornadoes. So we're going to go ahead now and just turn on the 1 day's worth of tornadoes right there. Excellent. Let's go ahead and turn off our base map here so we can just have a simple base map. If we turn this layer on, now we're seeing all the tornado touchdowns from 1950 to 2004. So does the 22 April 2011 pattern of tornadoes fit within the pattern of the historical tornadoes? Why or why not? Do some additional analysis on the historical tornadoes using the skills that you've learned in this lesson that you used on the 1 day's worth of tornadoes. Now that you've analyzed the data for 22 April 2011 and compared it to the historical tornadoes, now let's go ahead and download your own data from the same location where the 22 April data sets were gathered. You will compare another day's storms to 22 April, temporally and spatially. So this particular part of the lesson asks you to go out to the NOAA Storm Prediction Center, right here at this URL at noaa.gov. Scroll down to the place where you can enter a date. Select any date you wish. One interesting date would be the day that saw more tornadoes than any in the past 40 years, which was actually 27 April 2011, about a week later. This was the sad day in which many lives were lost in Mississippi, Alabama, and Georgia. If you use this date, you will obtain the following page and map. You can see the pattern here on this map on the web. Next, select CSV, not raw tornado CSV, but just plain old CSV, a comma-separated value table of the data, which you will bring to your GIS for further analysis. Save this CSV in your working folder. Open your CSV file in Excel. Observe some things, go back to ArcMap, and use the Add Data button to add the CSV file. You'll indicate what kind of data is incoming. And then what you will do then is map your 27 April, or whatever day you select, day, and compare it to the 22 April 2011 pattern that we were looking at earlier. Finally, in a paragraph, compare the day's pattern of wind and hail, temporally and spatially, to the wind and hail from the 22 April 2011 that you analyzed earlier. Synthesis. Give a 5-minute presentation to your classmates, as if they were the FEMA director, that includes your assessment of the 2 days of storms that you have analyzed. Use your maps and data to support your presentation and recommendations. Write a paragraph describing what you have learned about tornadoes, wind, and hail in this lesson. Write a paragraph describing what you have learned about the spatial pattern of a single day of severe storms and how GIS helped you to understand these patterns. I'd like to just add an additional note here. Inside ArcGIS Desktop, remember you've got these base maps that we were looking at earlier. Let's turn off the tornado touchdowns from 1950 to 2004 for the moment and go back to looking at this 1 day's worth of tornadoes. You know, we were looking at, for example, the tornadoes around the St. Louis airport. So let's go ahead and zoom over there. We have the capability of changing the base map, as you know. But since we're connected to ArcGIS Online, we've got all that wealth of data as well. So I'm going to go ahead and zoom into the airport. Okay, these were the tornadoes that were right around the airport that day. Now I'm going to change the base map. I'm going to select this Bing Maps aerial. Now I've got an aerial image showing the tornadoes on top of the aerial. Here's the airport. I'm going to zoom in there a bit further. And now I can see the tornadoes that were right around the airport that day, along with the runway and the terminal. So remember, you've got a wealth of data here at your fingertips. You're not limited to what I specified in the lesson. Here I'm looking at the tornado now in conjunction with these runways and the terminal, and there's another one out to the west. Remember, you've got a GIS at your fingertips. You can analyze and study spatial and temporal patterns of not just storms and tornadoes as we've looked at here, but a wealth of data. Anything that has a location you can analyze in a GIS.
Wasn't it interesting looking at 1 day's worth of severe storms? Did you notice how the pattern changed as the day went on? So we're linking the spatial perspective and the temporal or time perspective. When you think about it, there's a whole host of other data and phenomena that can be examined using a tool like ArcGIS Online, a geographic information system. Think about earthquakes, volcanoes, the location of businesses in your community, traffic patterns. A whole host of things can be examined because they take place across space and they also change over time. So I encourage you to use geographic information systems, including ArcGIS Online, to investigate phenomena in our world from a global to local scale that change over space and time. Thanks.